Good evening and welcome to the University of Sydney Faculty of Engineering and IT webinar series. Tonight we're going to be focusing on the School of Electrical and Information Engineering. My name is Paula Klaas, Head of Student Recruitment for the Faculty of Engineering and IT. The format for tonight's session is a presentation followed by a Q&A. So please feel free at any time during the presentation to use the chat or the Q&A to post your questions. With me tonight, I have Dr. Yash Srivastava, the Director of Undergraduate Studies for the School of Electrical and Information Engineering. As well with us, we have Jessica Fang, third-year student in a combined engineering and law degree. Over to you, Dr. Yash.
Thanks, Paula. I have some prepared presentation slides. Feel free to think of questions and ask them while the presentation is going. I'll give you, the slides basically give you a brief overview of what we do and what we are good at. So it gives you some idea of where we stand and what you will study. It's by no means complete, so ask questions, as many as possible. And that's the best part of this evening, I guess. So I guess the first up, we have some data on how good our students are in terms of employability. This is according to the most recent survey in 2019. University of Sydney is ranked 1 in Australia and 5th in the world in terms of graduate employability. In the School of Electrical and Information Engineering, there are two main degrees we offer: Bachelor of Engineering in Electrical Engineering and Bachelor of Engineering in Software Engineering. Most of these are probably intuitively obvious descriptions you can see in front of you. I'll give you, I guess, more common day scenarios where you've encountered these disciplines in practice. It's very likely that electrical engineering has touched many aspects of your life every day. If you think about the power supply coming to your home, telecommunication needs you have, as in internet at home, Wi-Fi chips you're using, smart games, smart TVs, biomedical devices such as cochlear implants, pacemakers. These are all a few examples of electrical engineering touching your everyday life. If you take a case in point, for example, a smartphone, many of you are probably carrying, it incorporates different things we do into one product. Part of the smartphone is a computer chip, essentially a digital circuit which is very small, and that's part of computer engineering, things we design. Smartphone needs to communicate either to your carrier or through internet, through Wi-Fi or antenna. That's telecommunication aspects of our discipline. Various apps you are running are examples of software engineering. And to make the battery life longer, you need to charge and optimize consumption of power for different use, and thus power electronics. High power versions of these things also are used in integrating renewable technologies such as solar energy, wind energy to your electricity supply. So this sort of gives you a brief overview of what different aspects are. And in the later slides, we give you sort of specializations our degrees offer you. They roughly fall along these lines. In terms of other things you see on the slides, Engineers Australia, and in the case of software engineering, Australian Computer Society accredits our degree and has some common components for accreditation need and also from employability perspective, such as internship, mandatory. There's more details coming up. You have big projects where you assimilate knowledge from different units and even different disciplines and apply to a practical setting, mostly in final years and smaller versions in other years. And you use state-of-the-art labs. So that sort of gives you a brief overview. In terms of majors, these are the different majors available for your degree. Most of them do align better with electrical, with the exception of computer engineering and Internet of Things and intelligent information engineering, which are also available for software engineering students. We sort of touched on these before. Telecommunication is led by our well-known research leaders and focusing on design, transmission, and coding of information while in the air or on the internet, such as NBN. Internet of Things is focusing on devices of the future. There is a projection that at the end of the decade, you'll have trillion devices all communicating to each other on internet. It's impossible for a human being to interpret that information. So we need automated process and some intelligence in processing that information. So Internet of Things measure addresses that sort of specialization. Intelligent information engineering is also about automation in interpreting different data coming from IoT and other devices. Explosion of data needs automated interpretation, such as in a video stream, you do want automatic capture of different scenarios. Computer engineering major focuses on the hardware side of devices, such as your laptops and mobile phones and other things. Power engineering is related more to transmission, storage of power, including renewable energies. This is one of the slides which is sort of focusing on telecommunication. And if you are, I guess, in the local community, you probably would have seen information on next bit of communication, low Earth orbit satellite and big center in Australia taking a leap into communication and space technologies. There was this cooperative research center announced just yesterday, which University of Sydney is a part of and focusing on satellite communication. This is sort of giving you, I guess, a brief overview of the sort of labs and equipments you would be using in terms of your curriculum and mandatory components. This probably does not do as good a justice. You probably had to see some of these facilities to appreciate them fully. So if you happen to be on a campus tour, by all means, stop by and we'll be happy to show you around. I touched on this before. Our degrees are accredited by Engineers Australia, and in the case of software engineering, it's a joint accreditation with Australian Computer Society. Engineers Australia is also part of a global accreditation system, which includes most of the developed world, including European countries and USA, Canada, etc. So your degree has recognition through mutual agreement between accreditation bodies from across the world. This is sort of summarizing what experience requirements your degrees have. We have taken a new approach, this is sort of first in Australia, to break up your engineering work experience throughout your degree, 4 years of degree, and integrating them with different components you learn during those 4 years. Overall, you end up doing at least 600 hours of professional engagement activities. And you can sort of see the breakup, things which you do within the units, things where you visit sites and engage with industries. And you also have a mandatory placement in the industry, so where you go off and work in the industry for at least 200 hours. These are some of the companies and universities we have, I guess, interaction with and opportunities to go on exchange, for example, to overseas universities, which is detailed a bit later in this presentation. Our students, this highlights, I guess, on a broad level where our students have gone on exchange, touches different parts of the world. University of Sydney has an aspiration to get 50% of the students to get an exchange experience. And we also have exchange students coming other way. So you may be sitting in the class with students from different parts of the world. Some of the exciting scholarships. This is one of the possible pathways you can take. Your curriculum lets you go and immerse yourself in industrial work experience for up to 6 months. If it fits, I guess, your degree structure well. Advantage being hands-on experience, real-life world experience, scholarship, and you do get paid while you're working, and you have already made inroads for probably a future employment once you finish your work. It is a bit selective and is available to sort of top students in the degree program. This is, I guess, this slide is already sort of covered. Main emphasis, I guess, here is you have a final year project which spans 2 semesters and requires you to do significant research and development work in a topic of your choice. And you do have different areas of specializations, as I had mentioned before. Okay, down to the entry requirements. If you're thinking of joining us, we have, I guess, a guaranteed 8-hour system. If you are a New South Wales HSC student, if you have an 8-hour of 92, you meet the entry requirements and no questions asked, no further qualifications, you get into the degree. Combined degree students have a higher cutoff if the second degree requires a higher cutoff. For those of you doing IB, it's 34. International students have a slightly lesser requirement. In terms of assumed knowledge, now it's become compulsory. If you are doing New South Wales HSC, we are expecting you have done 2 units of maths, and corresponding requirements for IB mathematics are on your screen. Please note that that's the minimum requirement. It's preferable if you have done HSC Mathematics 1 from New South Wales curriculum and physics. If not, university does offer bridging courses which run in February. The entry is open also for media. So with that said, I think I have said enough. I'm happy to take questions.
Thanks, Yash. Now we're happy to open to the panel, question and answers. Please put your post your questions. Hi there. This is Yash, that's Jessica, and I'm Paula.
So first question we have, is the work practical or theoretical in terms of what you do in a class?
I guess Jessica can compliment. I'm going to start by trying to answer that question. It's a mixture. What we pride in University of Sydney is to give you the fundamentals of science and engineering. So yes, it does require some theory, but you also are applying these to practical settings. So mixture of things. So starting first year, you may have more of theory. Starting second year onwards, you get into projects within the classes, which are of more practical nature. And by the time you reach final year, a big project is definitely practical.
Yeah, I think you can definitely see how the university splits everything in terms of theory and practical experience, and I guess the way the classes are actually structured. So for example, a lot of my engineering subjects, they kind of come in three components. One is a lecture, a weekly lecture, so that's mainly theory. Then you have tutorials, which is a 1 or 2 hour a week type thing where you do questions based on the theory. And then a lot of my engineering subjects also have a 2 or 3 hour lab each week. And during these labs, it's not so much the theory, but it really concentrates and focuses on the practical. So we build circuits and we put together everything that we've learned throughout the week.
I have a question here from someone. What units should I take in high school if I'm interested in electrical engineering?
If you're interested in electrical, the best, I'm presuming this is local? Or?
Yes.
Yes. If you're doing it New South Wales, SSC, Extension 1 mathematics and physics would be good. English is compulsory anyway, so those three things will set you well for our degree.
This is a very interesting one. In these courses, what's the gender split in the classes? What percentage of women are there in these classes? The university is actually, the Faculty of Engineering has actually a very high female participation. Could you tell us in electrical?
I can give you numbers. I do actually know that statistics. Electrical probably not as good as some other disciplines. We are improving. The last statistics I had, about 30% of our students are female, but yeah, still we have less females than male. Some other schools within engineering has a bit more, such as chemical and computer science have more 50-50.
Biomedical, right?
And biomedical.
Right. I think among other universities, we probably have one of the highest participation of women in the faculty. Another question about work industry experience. Do these hours also apply to other bachelors as a uni-wide thing or just in engineering? I would say.
So the work experience program, which you saw in the presentation, is the model for the engineering students. So the 600 hours are specifically for Bachelor of Engineering students across all the disciplines, so electrical, aeronautical, mechanical, civil, etc., all follow the same rules. Across the university is also encouraging more industrial placement, but it's not mandatory. So if you're doing, for example, a liberal arts and science degree, placement is desirable but not compulsory. For engineering student, it is compulsory, and there is a sort of minimum 600 hours of work placement, professional engagement, I should say, for engineering students.
The mandatory requirement for accreditation as an engineer is the 12 weeks, right? But we're asking students to do more. Am I right?
Yes.
The 600 hours is more than the mandatory, right?
Engineers Australia accreditation requirements is evolving. 12 weeks is one of the accreditation criteria put in their specifications. Not so many years ago, we used to have one block of working in industry for 12 weeks, which roughly amounts to 450 hours. We have expanded on that, but integrated that now through the 4-year of the program. In the old version, people did this end of 3rd year. Now you start getting exposure right from 1st year and build gradually towards 3rd year. You certainly can do 12 years of experience, 12 weeks of experience at industry end of 3rd year, as in the old-fashioned thing. So these are just the minimum requirements. You're welcome to do more. but it's more integrated now.
I have a question for Jessica.
Mhm.
How does university life differ from high school life?
It's very different. It's all up to you to, I guess, involve your things in, what you want to be involved with. So I find that in university, if you don't really want to make an effort to, it's very easy to slip in and out of class and not really know anyone. But in saying that, if you want to be involved, there's definitely so many opportunities in which you can be. So one of them is societies. At the university, especially within engineering, we have a lot of student-run faculties. We have our overarching one, which is for all the undergrad engineering students. Then in addition to that, we also have student societies based on each different stream. So we do have one for electrical engineering, which is called SparkSoc, and they do a mixture of social and professional, so industry engaging events. In addition to that, we also have societies within the engineering faculty based on other hobbies you may have. So whether that's whether you want to combine your electrical degree or software degree with humanitarian engineering, there's a society for that. Or even if you want to, I know we have a rocketry. Those sort of competitions as well, which you can get involved with. So basically, I think in university there is a greater, I guess, variety of things you can be involved with, but it's really up to you to put yourself through that.
I guess the only thing I would add is the biggest difference, and many of the students do come back and tell me, very first things go fast. 13 weeks is a typical semester from start to finish, as opposed to a school environment where you may last 4 terms. So things are more condensed, but less in number. So you typically do 4 subjects in one semester.
There's a question here in software engineering. Do you have to know how to code?
Good question. I think software engineering definitely needs to know how to code, but it's not an assumed knowledge. So if you're thinking you have no experience of coding in high school, that's perfectly fine. We do teach with no assumed background. In fact, not just software engineering, even in electrical engineering, I think all engineers need to learn to code. You can't be away from the computers and coding requirements. Electrical has its own set of specialist softwares for other units, but everybody does at least one programming course.
Okay, cool. I've got 2 questions here relating to career choices and work. And the first one is, what are the things you should consider when wanting to pursue a career as an engineer?
I'm assuming you have not started. So first of all, I guess, ask, do you like to understand how things work and build things to make your life and others' life easier? If the answer to that is yes, then you definitely want to be an engineer. It's a question of what flavor. And you can drill down to mechanical. So, for example, here we have degrees in mechanical engineering, mechatronics, which is sort of combination of mechanical and electronics, closely associated with robotics. You probably have seen applications into agriculture, manufacturing, etc. Aeronautical, chemical, and civil, and electrical and software I already spoken about before. Electrical is mainly about circuits. Our school name goes by Electrical and Information Engineering, trying to condense key aspects of things we do. Electrical encompasses traditional power generation, etc. Includes electronic circuits, be large scale or smaller scales, as in your laptops and mobile phones. And the part information engineering is tagged on for things which we do and not quite captured under the traditional electrical umbrella, such as image processing, signal processing, videos. I mean, take biomedical devices, for example, a cochlear implant is trying to improve your hearing, has electronic components, captures different sound signals, and their quality needs to be improved for the person to make any sense out of these, because these are hearing impaired people, and signal processing is an essential component of such things. So electrical and information captures that, and software, as I said before, as in developing engineering applications which require software solutions.
I think just following on from that, with having a career in engineering, what really comes across as a highlight and what potentially differs from, graduating with a degree in something else is that you can really see something tangible that you've created in your career. So I've been to quite a few industry nights and met people that work, professionally as an engineer. And when you ask them, what they love about their job or what they've done, they can be like, oh, this bridge? Yeah, I was part of the team that built that. Or, the T1 train line, I was part of the team that did the train signalling for that. And I think, when you've, been in a job for, quite a few years and whatever, it's really awesome to look back on that and see things in society that you've actually physically contributed to.
One question for you. Someone asked about combined degrees.
Yeah.
And you've taken a combined degree. Tell us a little bit about, why you chose your combined degree. What do you hope to get out of it?
Yeah, so I do a combined degree in engineering and law at the university. It's not one of the more popular ones, so a lot of the engineering students that do a combined degree often do it with commerce or arts even, and they're all really great options as well as science. The reason why I chose a double degree is because a little bit of indecisiveness, I think, and there are also a lot of areas that I was interested in. So in high school, I did a lot of maths and I did physics, and I love that. And I also did legal studies and, really hope to be involved with that side of things in my future career. And so one really great thing about the university and this course is that it enables me to do both of these degrees at the same time, and it actually helps me cut a year off if I did the degree separately.
And also she will be trained for handling things as patent laws, where knowledge of engineering is vital other than the law. Just to add, engineering law is very special combined degree with a higher cutoff determined mostly because law has a higher cutoff.
Thank you. Another question. What makes electrical and software engineering different to other branches of engineering? What do you love about these strands?
So going into electrical engineering in particular, I didn't really know what I was expecting. I thought it would just be, circuits, learning about power, and that's it. And what I found is that we kind of get a taste of a lot of the different other streams. So for example, as part of an electrical engineering degree, we do a lot of programming, which I'm seeing more and more to be just so useful in this day and age. So I've currently completed courses in Java, currently learning C, and touched on some other programming languages. Also in electrical engineering, I just love the practical side of it. So earlier I talked about the labs that we have on a weekly basis. That's 3 hours where you get into groups and you really get to apply the knowledge that you've learned during class. I know my first semester of electrical engineering, we had a project during one of our labs where we were able to build kind of like this robot on wheels, which was able to detect objects and make sure that they don't bump into them.
I should add, electrical and software are one particular focus, but all our engineering degrees are good, so it really depends, I guess, on your interests. I see another question on the bridging courses. How are they taught? Are there extra hours outside the normal hours? The short answer is the bridging courses run before semester 1. So this is sort of towards the end of summer break, typically in February. And we are running courses for chemistry, mathematics, and physics. If you are focused on electrical side and lacking background in mathematics and physics, that will be good. Physics is not a requirement for software, but mathematics is. But all of these courses run before you actually start your degree. So it's good to get organized and think about it. Information is on University of Sydney web pages.
Now this question, I think impacts a lot of people, and a lot of students ask about work experience, prior to coming. How do we get work experience? What's the experience like? So maybe both of you can, give us a bit of an idea.
You go first.
So especially with the professional engagement program, I've realised in the last couple of years at the university, and particularly the engineering faculty, has put in a huge focus on engaging students with industry. We get newsletters on a weekly basis, and we get emails, I would say every couple of days, basically showing us the opportunities that we can involve ourselves in. And those are things that it's done through industry and university partnerships. So I regularly get notifications saying that, there's an internship here, feel free to apply for this, or there's a site tour for this company, apply for this, or there's a social event at this engineering company, you're invited to go to this.
What have you done?
Yeah, and so, those opportunities are all great. At the end of, in the holiday that just passed, in the Christmas holiday, I just did my internship at Transport for New South Wales. So that was something that was also organised through the university. It was not complex. There was not too many frills around that, and I worked there for about 6 weeks, and I'm going back in the winter holidays and also at the end of the year.
There is a central repository, so we do maintain one site on the internet available to our students where all these notices are passed, and at least doesn't pass every week. Talking about different opportunities available, our site visits, etc. Having said that, the onus is still on the students to follow these up and apply. We certainly help you get in touch and provide you all the information.
There are two questions here. A couple of the students have asked about mechatronics. What are the requirements for mechatronics?
They require maths for me.
Yes.
Maths is across the board. Entry requirements now is 2-unit maths for all the BE degrees. So that includes mechatronics. And the electronics component in mechatronics is actually taught by our school and certainly does need maths. So it's helpful if you have done 3-unit maths. Only exception probably maybe civil, which can get by with a bit less maths exposure, but otherwise all the engineering degrees do need maths.
Okay, cool. This is a competitor question about competitors. Our competitor. How do we rate against UNSW similar program?
Both are good universities and both are good programs. I did tell you before that we are good in terms of placing our graduates into jobs. Engineering as a whole is a good profession with a higher median salary. I think last I remember from the government survey was median salary about 66,000 starting. You can't go wrong either way. They're intangible. UNSW is pretty much comparable to our degree. So I cannot say it's not good. Where we have intangibles is University of Sydney has a big history. It is the oldest university in Australia. And you're joining alumni, which is well placed in different walks of life. Just to give you an example, look in the list of representatives in the parliament and see how many University of Sydney graduates you see. If you go to a clinic, see how many of the doctors have University of Sydney certificate or degree on their wall. So you're joining a big family with a lot of good connections, which would do well in terms of future employment. But both degrees are similar.
This is a question about electives and potentially either of you. Do you get to take electives alongside the main courses, particularly ones outside the science, math, engineering, technology courses?
I think Jessica probably is not the best person to. Okay, let me rephrase this. You do have elective spaces for all the BE degrees, including electrical and software. But when you do get into combined degree, that's where I was sort of hinting for Jessica. The choice is sort of sacrificed to squeeze in the other degree. So take, for example, BE BSc degree. Standalone BE runs for 4 years, and standalone science BSc runs for 3 years. Instead of 7 years, the combined degree runs for 5. And way it works is to sort of strip 1 year from each degree. In this one, there are some synergies, but this 1 year of engineering is sort of sacrificed for a combined degree, represents your elective space in a normal 4-year degree. So 3 out of 4 years is sort of compulsory. 1 year is more free. There are some electives to choose from a list even within the 3 years. You certainly can do units within engineering, and there is some space to do units even outside engineering. For example, you want to learn German, you certainly can, up to a limit.
Okay, cool. Next question. How does computer programming integrate into other areas of engineering that aren't software?
Engineering is, I guess, much more complex than what it was 200 years ago. Even with a slide rule, we managed to send people on the moon, but each system now is much more complex, requiring hundreds of variables, and it's not possible to do things by hand. Software tools are definitely an important part of the solution. So for example, if you want to see how a big telecommunication system is working, or a big system in the news is power networks. You have integration of renewable energy coming from South Australia to New South Wales, and you have integrated to Queensland. How does this power flow? You really cannot do these computations by hand, and you have specialist software which help you. You do not get there overnight. We gradually develop these skill set throughout the 4 years. So starting from first year in the first programming language, we do have exposure to more specialist softwares for different applications in the next 3 years.
A couple of questions about coding again and language. Is there something, what code and hardware do you use?
First year programming course, which is compulsory, is now in Python. In terms of other softwares you use in electrical engineering, maybe assembly language programming if you're doing the digital devices. I'm not sure if you understand, something called MATLAB. It's a specialist software which deals with matrices and generally solving linear equations and nonlinear equations is good in terms of simulating dynamical systems. So we use that as a tool throughout many different units. Then you also have specialist softwares for power system simulation. Just to give you an example, telecommunication side of things does use a bit of C programming. There is a legacy code, a lot of it is still in C.
Cool. There's another question about that. Okay, so this is not an academic one, but a welfare-related one. So it's, what sort of support services are there for students who are struggling under the pressures of the university? And are there career counselors who help students who are unsure about their careers? How do you arrange meetings with them? Is it a free service? Yes, it's a free service. Yes, the university has services.
I think this is probably a complex question. I can touch, I guess, on a few different aspects of it. You definitely have advisors within the school to give you advice on academic side of things as to what courses are appropriate for you. And if you're struggling, what may be a good choice of direction. You also have student-supported units, such as counseling service, a service provided by the university, totally independent of the school. You also have student support services. You also have things like if you're struggling in maths, for example, there's a math learning center which can help you with things. So a variety of support services exist. And then there is informal network like what Jessica mentioned, with students in electrical having formed a society Spark Sox, where you can ask questions to other students who've probably been through what you are going through.
Okay.
Something that I found very unique about the engineering faculty in general is that when you go into the learning spaces, everyone loves to learn together. Not, every degree is it's like this, I guess. But, when we're working on like homework tasks, a lot of people love to learn together. The students that have already mastered the concepts love to teach others. So, yeah, there's definitely an environment and a very supportive type.
In terms of welfare and support, not academic, there are counselors here that are available to students at free of charge. There's a student representative counsellor as well, who supports students on all kinds of academic and non-academic related issues. And this is a free service to all students. And we have actually just time for one more question. And we may have touched on it a little bit, but I thought maybe we might do, what's the difference between software engineering and computer science?
Good question. We do have a School of Computer Science which offers a degree in Bachelor of Advanced Computing. And School of Electrical and Information Engineering is offering a degree, as I said, in Bachelor of Engineering, Software Engineering. The main difference between the two is the focus you take on things you learn. Both learn things like programming, and they are compulsory components, so you must learn programming, you must understand how to store and retrieve data efficiently, for example. How are the operating systems organized for devices you are running, big databases, that sort of thing. Where we differ is possibility of having applications which are more engineering focused in software engineering. You also have the opportunity to do a major, for example, in computer engineering, where you can pick up on the hardware aspects of your computing devices. You also have a mandatory work experience we had talked about a few minutes ago and during this presentation earlier. Bachelor of Advanced Computing does not have a mandatory work experience because not required to have accreditation through Engineers Australia. So those are the key differences. Having said that, if all I focus is on computer science related electives to fill my elective space in software engineering, the two degrees can look pretty much alike. I understand there is a slight difference in the entry requirements.
Okay, thank you so much. The last question, which is something that you did answer early on, but maybe you could wrap up this session with this question. How is engineering at Sydney different to other universities? Why is it better to study at the University of Sydney?
I think I can recap my previous answer. If you're choosing engineering degree, you can't go wrong. There are many good universities and degrees on offer. As in the earlier question, somebody asked me to compare with UNSW. This definitely is a good program. There are a lot of intangible things which University of Sydney offers. We are, as we touched upon in terms of employability of our students, we are very good. University of Sydney is the oldest university with well-placed alumni in different walks of life. Jessica touched on different extracurricular bits you could do or participate in while you are at University of Sydney. So these engineering in general, as you heard, is very collaborative. So students are supportive of each other and learn from each other. So you would enjoy working together with other like-minded, bright people.
Thank you so much, Yash. We'll have to end the session now, and thank you so much for attending our session. We look forward to seeing you at the University of Sydney next year. Thank you.